On December 2nd, 2025, the Helldivers 2 developers posted a tech blog announcing a beta release that reduces the install size from 154GB down to just 23GB. How is that even possible? Well, the TLDR is asset duplication and loading time optimizations designed for slow mechanical hard drives. But if you want a deeper explanation, stay tuned and hopefully you will learn a thing or two in this video. To understand how they did it, we first have to take a look at how mechanical hard drives read data compared to other types of memories. Today, we take SSDs for granted. They magically make everything feel snappier. Have an old laptop running slow? Just slap a SATA SSD onto it. You will hear this recommendation for consoles too, especially the PlayStation 3 and 4. That generation relied on mechanical hard drives, so an SSD upgrade can cut down loading times. And then there is the Wii U, the weird one as always. Depending on the bundle, the Wii U came with either 8GB or 32GB of eMMC. But the Wii U's eMMC was arguably even slower than mechanical hard drives. Old consoles like the NES, SNES, or Genesis used cartridges with virtually no loading times. This is because most cartridges use something called addressable memory. For example, let's take a look at the pinout of a Game Boy cartridge. You will see 16 address pins and 8 data pins. If the Game Boy wants to know what byte is stored at address hex 4123, the Game Boy has to set those address pins, and the 8 bits of data located at that address can be read on the data pins nearly instantly. But we all remember that period when consoles didn't have mass storage like a hard drive, and they had to load data from an even slower medium, optical media. Compact discs are an impressive technology. It has always fascinated me that you can shine a laser at a piece of plastic and somehow read the information written on it. Hard drives follow a similar principle, but with magnetism and at an even smaller scale. I am not going to explain how optical media works in this video. Instead, I recommend this video series from Technology Connections, and as of hard drives, I recommend this one from Branch Education. Even though I don't want to deep dive too much into how optical media and hard drives work, I still have to give you a brief explanation to understand why this is a problem. Let's say that you're playing a PS2 game. There are different formats for writing to an optical disc, but to keep it simple, optical discs can contain both files and audio tracks, guided by a table of contents that tells the system where everything is located. As the game loads, it has to seek the sectors containing the file data. To do this, the laser has to physically move to roughly where the file is located. Check if it landed on the right track, and if not, make small corrections to find it. This takes time because it is a physical action prone to delays and potential errors. On top of that, we also have to consider vibrations, turbulence, scratches, or dirt that may be on the disk. The laser also needs to make micro adjustments to stay in focus. And not to mention the times that the drive has to reread sectors because of a read error. Like I said, we may see optical discs as slow or obsolete today, but considering all of these factors, it is very impressive that they figured all of this out in the early 80s. Anyway, hard drives are technologically very different, where in practice they struggle with similar issues. Let's say that you enter a new room or area in the game. The game has to find the files for that area across various sectors of the hard drive platters. The first optimization that you can make is pack together the data of that section of the game. This ensures that the drive makes less aggressive movements because the data is read sequentially. But what if there are assets that are reused across multiple areas of the game, like trees or crates for example? This is where the other optimization comes in. You duplicate those files across the disk so that whenever the game needs to load a specific area, the asset is already in a friendly nearby location. The trade-off is obviously that it takes up more space, but the advantage is faster loading times and reduced pop-in open world games. And that is essentially the answer to the question at the start of the video. To reduce the install size of Helldivers 2, the developers mostly just deleted those duplicated assets, because they are not targeting mechanical hard drives anymore. And this isn't the only example either. Some games ported from PS4 to PS5 also saw their install size shrink because they were redesigned for SSDs. Unlike a spinning disk, an SSD can have its data fragmented everywhere without a performance hit. SSDs can pull a specific chunk of data from any random location on the drive, similar to that Game Boy cartridge we talked about a few minutes ago. However, we also have to keep in mind that many PS5 games also use Kraken compression to shrink files even further, making it a bit hard to find concrete examples of games getting smaller solely due to the move to SSDs. And let's be honest, some developers don't even bother removing the duplicated assets. A lot of times they just leave the game as is. Anyway, I wanted to experiment with this. So I decided to pick a game, find the duplicated files, and delete them to see if it makes any difference in loading times. The game I chose for this experiment is GTA San Andreas for the PS2. But first, a quick disclaimer. Even though this game has been widely modded for years, I have little to no experience with video game modding myself, so this is gonna be my first time ever modding a game. In case you are an expert in San Andreas modding, feel free to provide feedback in the comments. Second, while I found a few duplicated files during my investigation, it is hard to know if they were duplicated on purpose. And if they were, it is unclear if it was because of optimization or just dummy files to fill the disk. With these considerations in mind, I still pick San Andreas as our guinea pig, just because it is a very popular game and relatively easy to mod. Though this may have been a bad decision, you will later see why. That being said, let's get into the experiment. Okay, the first step is extracting the contents of the ISO file. There are multiple ways to do this, but for me, the easiest way is just using 7-zip. You can run this command to extract everything. The next step is finding the duplicated files. Again, there are plenty of tools for this, so I just ran a command to get the SHA-256 checksum of all the files and filtered out the unique ones to see what was repeated. Another thing that you can do if you're curious is run ncdu on the extracted folder to find the largest files. San Andreas modders may be very familiar with this, but the largest duplicated file I found was this gta3.img file. It is around 450 megabytes and the dub file is called gta3_1.img. However, we cannot just remove it willy-nilly. The game won't boot if either of those files are missing. We also have to patch another file called fileload.nm. Using a hex editor, search for GTA3 and you will find the GTA3_1 reference. Just replace it with GTA3, making sure that the file length stays exactly the same. You may wonder what gta3.img actually is. It is a file system in itself with a very specific file format. My guess is that it contains the core assets of the game, and we need specialized tools to inspect it. I found a tool called gta-img, and by using the inspect parameter, we can see the file name, offset, and length for every internal file. From what I can tell, the length is measured in sectors. Since each sector is 2048 bytes, a file listed with a length of 2, for example, would be roughly 2 kilobytes. Modifying these IMG files is quite tricky. We cannot just add or remove files arbitrarily because it shifts the offsets of every subsequent file, which causes the game to crash. One simple approach is to find their duplicates and point their entries to the offset of the original file. For this experiment, that would achieve the same effect as just deleting them. But I wanted to take it a step further by actually deleting the data to see the file size shrink. As I mentioned, that is much harder because you have to recalculate and update the offsets of every remaining file in the IMG. So with a bit of help from AI, I wrote a Python script to do exactly that. I ran it on gta3.img first, and it definitely got smaller. I then repeated the process for other IMG files I found. There were other duplicated files, so I ran a command to find where they were referenced. Aside from nnorm.ped and random.ped, I couldn't find any other references. It is hard to tell if those files are even used at all. Just out of curiosity, I tried deleting them, but that caused the game to hang at the title screen, so for now I will just leave them as is. It is now time to rebuild the ISO. I couldn't find any reliable way to do this on Linux, so I had to use image burn in a Windows virtual machine. And the ISO got quite a bit smaller, by around 480 megabytes. And I burned the unmodified ISO and my modified version onto two blank DVDs, because it wouldn't make much sense if we load the ISO file onto an emulator, especially considering that my host system uses SSDs. Okay, it is now time to put this to the test. There are different ways to approach this, but here are the methods that I went with. My first idea was to load the game from the disk using PCSX2 and record the gameplay inputs. At first it looked promising. I was able to play back the recordings multiple times without any desyncs, even though optical media read times are not always deterministic. However, when I tried to play back the recording using the modified disk, it was completely out of sync. Because even though it is functionally the same game, it is technically not the same game, so my input recordings are no longer compatible. For my next attempt, I simply drove around and entered some stores to force the game to unload and reload assets, and I finished the run at CJ's house. I repeated this process 5 times per disc, so 10 times in total, trying to play as consistently as possible each time. I know that this isn't the most scientific way of approaching this. For one, I am not using a real PS2 because I don't have one on hand. Also, the disk drive that I'm using likely has a far better laser than the one that the PS2 has. And of course, there is the factor of human error. But I want to see if there is any significant change in the actual gameplay experience. After finishing all 10 rounds, I imported the recordings into KDN Live. Time starts the moment the screen first goes black, and the time ends when this text fully disappears. While playing with the patch disk, I noticed that there is a lot more stutter. And I know it isn't shader compilation stutter, because I can hear the disk drive making noises every time the frame rate drops. Then I wrote down the results in a spreadsheet to calculate the average, minimum and maximum times, and it actually got better? Well, that was definitely not the expected result. What a waste of f***ing time. Whatever, I hope you enjoyed the video anyway. Bye!